Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to today's presentation. My name is Janine Donnelly. I am the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left side of your screen. I also want to mention that there will be an exit interview when you leave the webinar today. Your feedback is important to us, so we'd very much appreciate it if you would complete the survey for a chance to win a $50 American Express card. Today's webinar, Modernize Your COBOL Testing Processes, is sponsored by Compuware and SonarSource. Our featured speakers today are Stephen Kanza and Olivier Godin. Steve is a product manager at Compuware. Steve has extensive experience in agile application development and DevOps across a wide variety of technologies and industries. Olivier is co-founder and CEO of SonarSource, the company that develops and promotes the open source platform SonarCube, SonarLint, and SonarCloud. DevOps teams need an easy way to accurately track and validate the code quality of COBOL applications. Today, you'll learn how an integration between Compuware and SonarSource helps to accomplish that. So now, without further ado, Steve, I'll turn the presentation over to you.
Thanks, Janine, and I'm happy to represent Compuware. And for anyone not familiar with Compuware, Compuware is the largest mainframe-focused ISV in the market. Our goal is to be the best mainframe partner for the next 50 years. In 50 years is an intentionally bold statement based off our belief that the mainframe is the best platform for large enterprises' system of records. We offer a complete set of solutions that allow our customers to mainstream the mainframe with modern DevOps practices.
I'm Olivier Godin, the CEO of SonarSource, and SonarSource is a company that promotes continuous code quality, it is based in Geneva, Switzerland. We are still a small company, but growing. We have about 70 people working there, amongst which 40 are engineers. It was founded almost 10 years ago. And also it is largely based on open source software. We have today a very large base of customers. We have more than 1,000 customers, amongst which large and very large companies. Our mission is really to provide tooling to help companies improve their code quality. We have done that historically for, I would say, languages like Java, JavaScript, C#, but now we have a very large number of languages that we cover, amongst which also mainframe languages such as COBOL, RPG, PL1. And this is the reason we wanted to join Compuware today to do this webinar to explain how we can also bring code quality to the mainframe.
So I'd like to begin by talking about the challenges that many large enterprises find themselves in today. In today's economy, industries are being disrupted as software continues to eat the world and move IT systems from a back-end office role into the center of the customer experience. And large enterprises face these challenges by innovative companies that have the capabilities to bring solutions to market very rapidly. As you can see from the metrics on this slide, Although the majority of companies acknowledge their industries may be disrupted, less than half feel that they're adequately prepared for that disruption. One key area that companies focus on is preparing to change the digital culture of the company. And for most companies, this means transforming into a DevOps model. Adopting a DevOps culture has clear benefits in terms of the ability to respond faster to business needs while improving collaboration between silos. These silos can exist between teams, and they can be amplified by process tooling differences that may exist across platforms. Additionally, as we'll be focusing on in this webcast, modern DevOps approaches can have a dramatic impact on the quality of the applications being delivered. So not only are you able to deliver applications faster, but you can do so with improved quality. But a key factor in achieving these types of benefits is focusing on the software delivery pipeline and how to maximize the throughput of code through that pipeline while maintaining high quality. It's important to understand the flow that your software goes through various stages and focus on automating time-consuming tasks that require manual handoffs wherever possible. The goal is to have ideas to improve the business capabilities of IT systems flow as efficiently as possible from the developer who codes the capabilities out to production where that value can be realized by the business. These types of highly automated pipelines have evolved in their origins from continuous integration practices and extreme programming practices that highly successful Agile teams put in place years ago, and now reach out to the deployment and operational aspects of the IT systems to provide more feedback into the system to improve the throughput and the quality and the operational impacts of the IT systems. The evolution of modern pipelines needs to focus not just on automating manual processes as they exist today, but also reinventing the approach completely in many cases to ensure that code is being produced with high quality and it's easy to maintain going forward. But a company's delivery pipeline is ultimately constrained by the slowest piece of their IT system. What we found in engaging with various customers is there's often a fractured ecosystem within enterprises between systems and teams working on cloud, web, and mobile applications, and those running on mainframe systems. Organizations, particularly over the past decade, have focused on building cutting-edge delivery pipelines and distributed systems, but more often than not, mainframe teams have not been involved in the evolution of DevOps practices over the past decade. But that needs to change in order for companies to improve their throughput. Many mainframe teams are still practicing traditional waterfall development cycles that involve a large amount of manual handoffs and manual testing. They lack the degree of automation that provides quick feedback to the developers that allows them to understand the coding changes and get feedback on that in a very rapid fashion to improve. To highlight this, I'd like to share a story that a customer recently shared with us when they compared their distributed technologies DevOps pipeline to their mainframe pipeline. On the distributed side, a developer could make changes to code and then have those changes flow through multiple layers of automation with quality checking without further human interaction. And this allowed them to produce software in a very automated fashion, in a very high quality fashion. On the mainframe side, the same type of change required manual quality checking, and it also involved 7 days of pure idle time while things moved from one task to another and having a person wait for that process to complete before they could move back to their work. By the time feedback was given to the developers, they had likely moved on with other tasks, and they lost a lot of the context of the code that they had changed. There is no quick feedback loop that allowed the developer to learn and improve, and also no consistent approach to managing quality across the enterprise. As the pictures illustrate, these two completely different ways of working were worlds apart. The problem is compounded by the fact that in this particular company, 60% of the processing and data resided on the mainframe. So the company's ability to innovate was constrained by differences in the way they work and how they approach the quality process. These differences reinforce silos across the organization, and it leads to frustration as business initiatives are impacted by these different delivery methods and different cultures that are evolved around these processes. So before I turn it over to Olivier, we wanted to take a quick poll to get a sense for the audience's experience with mainframe quality practices.
All right, thanks, Steve. So, ladies and gentlemen, as you can see, we've launched a poll. We're looking for your input to this question. Do you have a practice in place to manage code quality for your mainframe applications? So pretty simple, pick your answer and hit submit. We will compile the results and share the results with you. So Steve, results are coming in here, and we pretty much have a quorum. That's kind of what I was waiting for there. I'm going to go ahead and send these results out to the audience.
Okay, and this is an interesting result. So it looks like the majority of people do have a quality system in place to manage their code quality on their mainframe systems, but there's still a pretty substantial portion of people out there that don't have that quality system in place. So at this point, I want to turn it over to Olivier to talk a little bit about SonarSource's unique approach to quality management.
Thanks, Steve. So first of all, what I would like to do is to define code quality as we see it at SonarSource. So at SonarSource, when we talk about code quality, which is really the domain we want to cover, we are actually considering three types of quality. One is we are talking about maintainability, which is also known as technical debt, where what we are trying to help company with is their future maintenance. So basically, anything that we are developing today, we are going to have to maintain tomorrow. So if we are not careful, we might end up paying back some debt as we go along. At some point, that debt might become so big that it's not possible to make an application evolve anymore. And in that case, we would have to rewrite it, which is kind of a bankrupt. And this is very costly. So this is the first area we look at, we focus on, and this has been historically the part we have tackled. The second thing we are looking at when we talk about code quality is really reliability. So here, what we are talking about is potential bugs. And we are talking about technical bugs that we are trying to detect. So things like trying to use variables which are not initialized, things like not closing properly resources, things which are more which are suspect, like you have this condition which is always true or always false, which probably means that something is wrong somewhere. It was not meant to behave this way. And generally, these problems are going to happen in production. So they are generally runtime issues. On the last area we are considering when talking about code quality is security vulnerabilities. And this one, we are really entering it. We started last year, and we intend to add more this year. So when we are talking about code quality at SonarSource, we are not talking about performance issues or legal and compliance, which are slightly different areas. So that was my first take on this, which is really a definition of code quality. I thought that almost 3/4 of the audience has a code quality practice in place already. So that's very interesting because I'm sure that you guys have had some challenging in putting that in place, especially if you want it to be enforced, real, and efficient. On the main challenges that you get when you want to put that in place are the following. First of all, it very often comes too late. Very often, code quality comes after the development was done. Doesn't really matter whether it's in an agile environment or more in a waterfall environment. It is a challenge when it comes at the end because the feature is already developed. Everybody is just waiting for it to be pushed, to be shipped to production. And when you come back with some feedback about the quality of code, some of it might be taken into account, but generally it's going to be only the cosmetic stuff. Anything which is a little bit structuring is going to be delayed to be resolved later. So that's a big issue. The second thing is that we find out that in many organizations, this feedback is coming from QA teams or auditing teams. So it's basically coming from outside the development team, and the dev team tends to push back on this feedback. There are many good reasons to push back, like that was difficult, we had challenges, the code has changed already, I'm working on the new version, and the business is waiting for it, etc. So there are lots of good reasons to push back, which kind of means that we come to a situation where nobody really owns code quality. In such organization, the QA team doesn't really own code quality, and development doesn't own it either. The last thing which is pretty challenging in organizations when you want to implement a code quality practice is the fact that because there is a high diversity of applications, it's actually very difficult to come up with expectation of in terms of quality. So basically, when you are talking about requirements, what can we expect in terms of code coverage by unit test, in terms of number of issues, etc. The answer in many organizations is very often that it depends. It depends about whether it's a legacy application, whether it's a more modern application. It depends on which language it's written. It depends whether the team is more like a senior team or it's more like a junior team. It depends whether it's outsourced, insourced, etc. So it's very difficult to be able to come with some requirements that are going to apply globally to an organization. And because of all these challenges, actually it is very, very difficult in such organization to put in place what we call a quality gate. Quality gate, this is a very simple concept, which is that you are basically defining a list of criteria that are going to have to apply in order for you to be able to ship the release, the code into production. So basically, it's kind of a switch, it passes or it fails. And because of all the challenges I've mentioned, it's very difficult to be able to come in an organization and say, okay, from now on, every code which should ship to production, we will verify that the quality gate passes. If it fails, it goes back to development. At SonarSource, we actually have a pretty simple but powerful approach in order to be able to put in place a quality gate, which is represented on the screen right now, which is that we actually propose to manage code quality as you would manage a water leak. So for water leak, it's very simple, very intuitive. You know that the very first thing you need to do when you have a water leak is actually to fix the leak. You should do that before you do anything else. Otherwise, it's just a waste of time. For code quality, we are actually proposing exactly the same approach, which is that before looking at anything else, you should make sure that the new code is under control. So basically what we are proposing is that all the new code is going to go through inspection, and only that will stop applications to go into production. In other words, what we are proposing is to make sure that the new code has the right level of quality. So no new blocker, the right level of code coverage by unit test, etc., etc. And this is very simple. It may sound simplistic, but it is actually very, very powerful. As an example, I would say that at SonarSource, we have struggled at some point to raise our code coverage by unit test. We wanted to have like 70% of code coverage, and we were struggling at like 68, 69, and we always had to do the extra mile at the end of the development in order to be able to reach the 70. After a while, we thought about that, and this is when we came with the idea of looking at the new code, and we decided that we could only look at coverage on new code. Since then, we have been able to reach, I think we are at 87 or 88% today, and that was gone. That this quality, this code coverage actually increased very slowly, very steadily, no big hit, no gaps, etc. Just by making sure that on the new code we would have more than 80% of code coverage. So very efficient to improve code quality. And actually, if you think about it, you also, when you do that, you also remediate existing debt automatically, because by nature we keep changing software. So basically, all the areas that we are changing of existing code, they are actually going to have an increased quality. I'm now going to switch onto demo of to basically show you the main features of which support what I just described. So first of all, I would like to show you what quality gate looks like. So this is actually the default quality gate that comes with SonarCube. You can see that it is very, very simple. Code coverage on new code should be greater than 80%. You shouldn't have more than 3% of cloned on your new code. Your maintainability should be A on the new code. Reliability should be on the new code. Security should be A on the new code. So basically, what we are asking developers to do is just a good job. We are asking developers not only to develop the feature, but also to develop it with standard code. First thing, you can see here that you can actually define your own quality profile. Also, I would recommend to use the standard one to start with. We have some people at SonarSource who actually prefer to have more code coverage, so they want to be at 90 rather than 85. So we call it the Champions League quality gate. The second thing I would like to show you is that it's very important when you look at code quality, when you look at various applications, to be able to get the big picture. So there are many ways in SonarCube to show you the big picture, so you can get a perspective by rate, by reliability, security, maintainability, coverage. You may want to get the leak perspective. So here, basically, we are showing the status of quality gate for the current iteration of development. We also provide some ways of consolidating data, so getting the bigger picture. And now I would like to switch onto project dashboard. So when you look at a project or program dashboard, there are really three areas we want to highlight in SonarCube. First of all is we want to provide the actual quality. So this is the part on the left here. Here we have currently, so I'm showing you SonarCube in SonarCube, so our own stuff. So we currently have 3 open bugs in SonarCube, no security vulnerabilities, some code smells, so some technical debt which would require about 60 days to remediate. This is an estimation. Our coverage, I underestimated it. It's actually almost 90% by unit test. We have about 15,000 unit tests on the application, and we have about 1% of code which is duplicated. So this is the actual quality of our product. On the right-hand side here, the yellow part represents how we are doing in our current development sprint. So here is basically what we have introduced as quality problems, so no new bug, no new vulnerability, almost 80 new code smells. We have currently coverage of 94% on the new line, so any line that has been touched or added is considered actually as a new line, on 0.6% of code which is duplicated. And the last part, which is very important, is here. In real time, we have the status for the quality gate. So basically, currently it passes. It's not always the case, and it's also interesting to do demos of our own product when it doesn't pass. It shows that it happens everywhere. And what's also very interesting here is I am actually able to click on any of these data to get some more information. I'm able to drill down to get a breakdown. On here, I can have many different views on this information. So 77 code smell, 35 of them are critical. I'm only interested on this, so I can actually click on it's going to filter out, and eventually I'm able to click again, and I'm going to see the source code, the underlying source code. So I'm getting the issue in context. I'm getting also extra information here. I know who introduced this problem, who changed this line, at what date. And I'm finally able to there is a little flow to be able to manage issues here. Same applies. So this is for issues. Same applies to metrics. You get lots of different angle to see metrics. You can see the code. You can see activity. So many different angle for this. It is possible to see the list of rules that is being used in order to analyze the project, so per language. So we do not write COBOL code at SonarSource, so here I do not have the COBOL language installed on our instance, but you would be able to browse the rules if it was. The last thing I would like to mention is that on top of what I just showed you, which gives you a lot of information about the quality of your application, you are also able to get this kind of information in the IDE as you write code. So we have a product which is called SonarLint, which actually gets installed in the IDE, and we support all the major IDEs, Eclipse, Visual Studio, IntelliJ, and for Eclipse we also support it for COBOL through integration with Compuware Topaz. So once you have this installed, it's actually possible for the developers to get on-the-fly feedback on issues they are introducing. So from a leak management point of view, it's actually you are able to not even introduce the issue because you get immediate information in your IDE. And I think that's it for the demo. Now we are going to have a second poll.
Great. Thanks, Olivier. Okay, ladies and gentlemen, we have launched that second poll. Question is, do you apply automated testing to your mainframe programs? So again, we'd definitely appreciate your response. And again, we will be sharing the results with the audience. And the results are coming in. While we wait for those, I want to remind you that in coming days you will receive a follow-up email. So be on the lookout for that. It will contain a link to the recorded webinar. And Olivier, I want to give this one more click here to roll up these results. Okay, let's go ahead and send these results up to the audience.
Actually, it's kind of the other way around as before. So most people do not have automated testing on their mainframe, which I believe is kind of interesting, and it's actually a good transition to hand it over to Steve, who is going to talk about automatic testing on the mainframe.
Yeah, thanks, Olivier. And as Olivier demonstrated, SonarCube is a very powerful tool to measure quality and manage technical debt. And interestingly, with the poll question, when Olivier and I first met several years back, we recognized that the mainframe ecosystem lacked the ability to leverage these capabilities within SonarCube in a robust way. And we set down a path to address some of these shortcomings and close the gaps in terms of how quality is approached on the mainframe. So where we started was making it easy to get mainframe source code scanned by SonarCube, and also giving mainframe developers access to SonarLint directly in their IDE. And in terms of automated code quality, Compuware, a little over a year ago, released the first automated unit testing solution for mainframe COBOL batch applications in Total Test. And we've continued to build out the functionality and the environmental support around Total Test. And we moved next to be able to integrate those automated unit test results in the SonarCube. And most recently, what we've done, as the slide indicates, is we've integrated code coverage metrics for COBOL applications also in the SonarCube. So with these capabilities that we've delivered, we can now build out a mainframe continuous integration pipeline that can be triggered automatically every time a developer promotes their code within ISPW, the SCM. And that pipeline can automatically trigger these automated tests and collect code coverage metrics that can be fed back into SonarCube to verify that that code meets the quality standards defined in the quality gate before it's moved higher in the life cycle. So this is a critical thing to have this type of quality gate in place so you can manage that code quality and you can make sure you get developers fast feedback on those changes and prevent bad code from making it higher into your life cycle and getting issues reported on it much later in your life cycle. So two key critical Compuware solutions that I'll be demoing related to this tool chain are Topaz and ISPW. And Topaz is the next generation IDE for mainframe development. And it connects Compuware's mainframe tools for faults and fault analysis, data, and performance management tools, as well as integrates in mainframe source code management and mainframe debugging capabilities. Topaz also provides additional capabilities on top of the historical Compuware tool set for managing enterprise data across mainframe and distributed platforms and understanding complex data relationships that may exist in those platforms, and program analysis for understanding complex program behavior, both from a static analysis perspective and a runtime perspective. And it's really critical for developers in mainframe applications that may be working with a very large code base that's been developed over years or potentially decades to be able to quickly understand that application behavior so they can modify it to meet today's business needs. And lastly, Topaz for Total Test, like I had mentioned, that brings automated unit testing capabilities to mainframe application development and addresses what is a clear gap, as it can be demonstrated in the poll results, of the lack of automated testing in the mainframe application development space. Another key solution in building a mainframe delivery pipeline is ISPW. And ISPW is Compuware's modern mainframe SCM that's designed to support DevOps practices. ISPW handles source code management, the build and deploy processes for mainframe applications, and it also has integrations and APIs that allow it to be connected into DevOps tools like Jenkins and SonarCube. And ISPW provides modern interfaces both within Topaz and web interfaces and through the integrations with other DevOps tools. With Topaz and ISPW, it's possible to build a mainframe inclusive DevOps tool chain that's built with best-in-class DevOps tools. And these tool chains allow developers to work in an integrated, seamless environment across platform and build out DevOps pipelines that can take code from the point of a developer making changes and ultimately move that code all the way out into production in a highly automated fashion. The mainframe no longer needs to be an isolated entity and can be an active and equal participant in enterprise DevOps. And this can help improve both your throughput and quality, as well as break down the organizational silos that have been built up around having a disconnected culture, process, and tools between mainframe teams and distributed teams. So now I'm going to move on to a brief demo of how some of these capabilities can manifest themselves. So if we can go ahead and push the screen share. So I'm going to start in Topaz Workbench, and you can see Topaz Workbench is a modern Eclipse-based IDE, and it allows me to get access to my source code and my data that may reside on the mainframe and easily access it in an intuitive interface. So in this case, you can see I have a program up in an assignment inside ISPW. And as Olivier mentioned, one of the first capabilities we brought to market in integrating SonarQube in Topaz is the ability to have SonarLint work within Topaz. So you can see here, SonarLint has analyzed my code, and I can see that I have a set of issues that SonarLint has detected within my code. So now as a developer, I can see that I have some problems that I may need to correct. So looking here, you can see that I have a particular issue, and a really great feature of SonarLint is, as a developer, I'm able to not only see that an issue is detected, but I can also see information about that issue in examples of compliant and non-compliant code, so I can get an understanding of how my code may need to be changed in order to address this issue. So in this particular case, you can see that I'm moving data to a variable that might not be sufficiently large enough. And so to address that particular issue, I'm able to, using SonarLint, I can go in, I can find where that variable is defined, and I can make modifications to that, and I can save that change, and I can see that now I've addressed that particular issue. And you can see here I have a whole set of issues related to another variable. I can follow that same process in, again, using information from SonarLint. I can address that issue. So now I've made some modifications to my program and addressed a lot of these issues, but just modifying these things doesn't give me 100% confidence that I haven't impacted this application. So what I want to be able to do is I want to now recompile this application. Oops. I'll go ahead and kick off the generate process, which in ISPW will recompile that program. And once that's complete, I can use total test. You can see here I've gotten a notification that my compile is complete. And I can use total test to run a test scenario against that program. And I'm also going to collect some code coverage metrics on that program at the same time. So I'll go ahead and kick that total test off. And if you'll recall, some of the areas of the program that I modified were in several of the paragraphs of the COBOL program. So you can see here that my tests have passed. I have a 100% success rate for my automated tests. And I can also drill into the code coverage, and I can make sure, for instance, I know I changed the variables that were moving data in this particular paragraph, and I've covered that particular paragraph. In another paragraph that I also made some modifications to the data variables was in this paragraph, and you can see I've also covered that particular paragraph. In using total test, I'm able to not only run the program with data that I may be using as a developer, but I'm also able to use total test capability to stub out data. So in this particular program, my program calls two subprograms and reads and writes data into several report files. And you can see total test has captured all that information. And if I want to now modify my testing to include additional scenarios, I can easily do that from total test and rerun those scenarios to increase my code coverage and give me higher confidence that the modifications I've made to my program are going to be of high quality. So the other aspect of this is, you can see I am at my development level within ISPW, and I'm going to go ahead, and now that I'm confident that I've done my due diligence as a developer and I have feedback that my coding changes are good. I've addressed some issues. I now want to promote that code up from my development level in ISPW up into my QA level. And in my QA level in ISPW, what I've done is configured a Jenkins continuous integration process to run. So now, without me having to trigger anything, my automation pipeline process can trigger this DevOps pipeline. And the first step in this pipeline is to retrieve code from ISPW so it can be scanned by SonarQube. Then I'm going to run a more comprehensive set of regression test cases from total test against it, collect code coverage metrics on the testing, my automated testing that I've done, and then check against a SonarQube quality gate. And if my code meets that quality gate, it's able to progress higher in the life cycle where it can be promoted up into higher level environments. If and you can see in this case it's passed, if my code did not pass that automated quality gate, you can see it would be rejected, and I wouldn't be allowed to progress that code further up through my system. The way this pipeline is triggered is, again, through ISPW, which has the capability, like other modern SCMs, to define a webhook. And in this case, I have a webhook set up for my application to trigger my Jenkins job based off any promotions that I have from my development levels. And the pipeline itself is leveraging several Compuware plugins that we built to Jenkins. So we have the first plugin that we produced to be able to get source code out of ISPW, Endeavor, or PDF files resident on the mainframe. We have the ability to run total tests from Jenkins, and we have the ability to extract code coverage metrics from our Expediter code coverage product, again, to feed those metrics into SonarQube. And then we have the ability, based off that quality gate, to trigger actions such as promoting code further in the life cycle, or maybe rejecting code back down to the development area in ISPW if that code doesn't meet the criteria we've defined within that quality gate. And again, you can see that for my COBOL project, I've pushed metrics in the SonarQube, and I do have that passing quality gate. I have some bugs, but no net new bugs, and I can also look at my coverage metrics within my code. I could drill down and look specifically on code that I've covered or have not covered very easily from SonarQube in the same manner that you would do for other applications. So with the technologies that we've built over the past 2 years, we do feel that we've taken mainframe development practices and really enabled our customers to close that gap in quality practices that existed historically as compared to distributed technologies. So with that, I am going to turn it back over to Olivier.
Thanks, Steve. That was a very complete demo of what we have built together indeed. So I would say that as a conclusion, at SonarSource, our perspective is that really we have closed the gap for code quality management for the mainframe. So we SonarSource started from Java. We built lots of stuff. We have now managed to close the gap with the mainframe environment. We have all the metrics. We have a lot of rules. We manage duplication. We now have unit tests, code coverage on new code for mainframe. Compuware has built the orchestration, which is a very important piece when you want to automate all of that. And we have IDE integration with SonarLink being available for Topaz. So we are going to continue to work on this, but we don't feel that at this stage there is any big gap that needs to be filled, and this is all ready to be tried on to be used by all of you guys. And that's it for me.
Great, thank you, Olivier. Before we kick off the Q&A, we very much appreciate it if you would complete the survey as you exit today. Don't forget, you'll be entered into the drawing for a $50 American Express card. So with that, we have some great questions coming in, so let's get started. I'm going to go ahead with this one, Stephen. You might have to add some clarification. The question is, what is code quality, defects, or coding standards?
So I think Olivier covered some of that when he was talking about the definition in terms of code quality. And from a code quality perspective, we're talking about defects that are detected from SonarQube that are classified as bugs, where there could be a runtime issue, but also coding standards, which are usually grouped together in a code smells type area within SonarQube that look at the is this code look right? Is it meeting the standards that an organization's defined in terms of how code should be developed?
Okay, next question. Are we talking about the security and reliability in COBOL code or on distributed side?
We are talking about on both sides. For security specifically, what we provide today is pretty light, but for reliability, we are very strong on distributed and mainframe.
Okay. What exactly does security vulnerability mean for mainframe applications? And they request that perhaps you could provide an example.
I think at this point we can say that we mainly focus on maintainability and reliability when it comes to mainframe. So I will not provide an example.
I think there's a couple requests about this. Is there a trial version of COBOL Sonar, of the Sonar products?
Yeah, absolutely. I think just after the Q&A, we are going to have a screen where we have we are going to share resources, and this is possible to request trials.
Excellent. Is Sonar supporting COBOL 6.1?
Yes.
From Topaz code coverage perspective, what needs to be sent to SonarQube to provide the coverage report?
So from the pipeline that I showed, you can see that we've built an integration to pull our code coverage metrics out of the code coverage repository that exists on the mainframe within our Expediter code coverage product and generate the format that SonarQube needs in order to consume those coverage metrics back into SonarQube. So it's a combination of pulling the source code that you want coverage metrics to be captured against, and then pulling the code coverage metrics, and then running both of those into SonarQube through SonarQube's Jenkins integration.
Okay, next question. Are there possibilities to identify code duplication across multiple applications? For example, the entire COBOL code base.
Yes, absolutely. It takes a time on the resources, but you can, as far as I'm aware, you can analyze as much as you want, and duplication is going to be searched across the whole range of programs.
Great. Does SonarSource also check the SQL statements in COBOL code?
We do. There is a set of rules that we have that will check SQL code inside. I think we have to be honest here on there are less rules that check the SQL, and they are also less advanced. But yes, we have a set of rules.
Okay. We talked about the free trial. I'm going to go down to this one. Working on the pipeline and setup for automated testing implementation. Okay, so that doesn't have a question in it. I'm going to go to this one next. What was the relation of Sonar to COBOL? I don't know if that...
Good relation.
What is the bug tracking tool that SonarCube interfaces with?
Well, I think that there is I'm not exactly sure about this question, but it's actually possible to link any bug tracking tool with SonarCube simply by using, we have a system of permalinks, so whenever there is an issue that you want to reference in a bug tracking tool, or also if there is a group of issues, you have the ability to create some tags. You can tag these issues, and then you will be able to have a permalink on the reference onto this tag, so we can basically integrate into any bug tracking tool.
Okay. I'm kind of running out of time, so I'm going to jump down to this one with maybe not too long an answer. How do I download the existing rules for certain language in SonarCube?
We have an update center, so you can download that from the update center. Alternatively, you can download them directly from our website.
Great. Then that leaves me time for one more. Does SonarLint take different COBOL 6.1 options into consideration when looking into the code?
Ouch.
Okay.
That was not the right question for the last one.
It's too much detail.
This is too much COBOL for me.
Well, here is the deal. We have had a tremendous response from our attendees in the way of questions. So, ladies and gentlemen, I just want to let you know that if we did not get to your question today, we will reach out to you via email. So watch for that. You will get an answer to your question. Unfortunately, that's all we have time for today. So I want to thank everyone for attending today's webinar. And I especially want to thank Steve and Olivier for sharing their expertise with us today. Later this week, watch for a follow-up email containing a link to the recording of today's webinar. That concludes our webinar. Thanks again, and have a great day.